In part 5.2, we're going to talk about how to balance chemical equations to ensure that we are getting a true mass balance. So just to describe a little bit about what we're going to do, and then I'll go through a couple with you. Writing a balanced chemical equation for the reaction of propane, which is C3H8, with oxygen, O2, to form carbon dioxide and water. So the first thing we're going to do is we're going to write the equation. So we're going to write propane, which is C3H8, added to oxygen is going to form CO2 and water. And this is the formula for propane. This is the formula for O2, CO2, H2O. We are never going to change these numbers that occur right here. We can only change the numbers that go in front of them in order to make sure that we get an actual balance. So the first thing we look at, and you can do these multiple ways. You don't have to do them exactly the same way I do it. I just show you kind of what I do. So the first thing is if you balance the carbons, we have a C3, okay? So we know that that can't change. We've got 3 C's over here. This one only has like a C1, okay? So 3 times 1 would be 3. So if I place a 3 in front of that, I'm going to then have 3 carbons, but I've also added more oxygens because everything that I put this in front of, I've got to multiply their numbers by 3. So that gives me 3 carbons on the left and 3 carbons on the right. Then I look and I've got 8 hydrogens and I've got 2 hydrogens over here. So I ask myself, what do I have to multiply that by to get 8? And the answer is, if I have 2, I'd have to multiply that by 4 to give me 8 on this side. So I put a 4 in front of the H2, and that gives me 4 times 2 is 8 hydrogens. Now I usually leave oxygen to last because especially if it's got an oxygen by itself, because now that I have put the 3 in front of the CO2 and the 4 in front of the H2O, I've got 8 hydrogens and 8 hydrogens and 3 carbons and 3 carbons, and so I now have, I had 2 O's over here, and I have 4 times 1 is 4 oxygens, plus 3 times 2 is 6 oxygens, so I've got 10 oxygens on this side, and then I didn't have, before I added the 5, I only had 2 on this side. So then I say, okay, I've got 2 on this that I cannot change, so 2 times what would give me 10, and the answer is 5. So if I place a 5 in front of the O2, then that's going to give me 10 oxygens. And so then I have 3 C's, 8 H's, and 10 O's, and 3 C's and 8 H's and 10 O's on the right hand side. And then the last thing you want to do is you want to make sure that you've got the lowest whole number ratios, because if you have something, if I had numbers in front of all of these that like I could divide by 2 or 3 and reduce those, then you always want to reduce them down, and that happens sometimes if you have way too many things. So just kind of keep that in mind. Alright, I just want to do a couple of examples of these just to kind of give us a few more to do. So let's say, and let's use some hydrocarbons again because they're typically the hardest ones. So let's say we're going to have sorry about that. We're going to have C5H12 plus O2. And if you recall, this is a combustion reaction. And in a combustion reaction, the products are always CO2 and water. If you're combusting an organic compound, that organic means it only has C's and H's. All right, so the first thing that I do is I take inventory of what I have on each side. So on my left-hand side, I have 5 C's, I have 12 H's, and I have 2 O's. On this side, I have 1 carbon, I have 2 H's, and I have 3 oxygens. So I have 2 plus 1 equals 3 oxygens because they're in 2 different molecules. So, and that's another reason why most of the time you're going to want and wait to do your oxygens last, because sometimes they're a little more complex. So we have 5 carbons on this side and only 1 on this side. So what can we do to give us 5 carbons? We can't put a 5 there, remember, but we have to put it as a coefficient in front. So that would then give me 5 carbons. But what has it done to my oxygens? It's given me 5 times 2, which is 10 oxygens, and I still have the 1, so that gives me a total of 11 oxygens right now. Okay, now let's look at our hydrogens. We've got 12 over here, we've got 2 over here. What can I multiply by 2 to give me 12? Well, 6. Okay, if I multiply, remember, if I multiply the 2 by 6, I've also got to multiply my oxygens by 6. So 6 times 2, it gives me 12 hydrogens, and 6 times 0 gives me 6 oxygens. So that's a total of 16 oxygens because I have 10 here and 6 here. And on this side I have 2, so what times 2 gives me 16? So I have to multiply that by 8. And so if I multiply that by 8, it gives me 16 oxygens. And then I have 5 and 5, 12 and 12, and 16 and 16. Perfect.